We already completed bubble sort, insertion sort, and selection sort. Today let us see merge sort. Merge sort uses divide and conquer approach. Its worst case time complexity is much less than previous sorting algorithms such as bubble sort, insertion sort, and selection sort. Merge sort worst case time complexity is big of n log n. Many algorithms are in recursive in structure to solve a given problem. Recursive algorithms calls themselves to solve related subproblems. These divide and conquer algorithms break the problem into several subproblems that are similar to original problem but smaller in size. Solve those subproblems recursively and combine these solutions to create the solution to the original problem. Conceptually, merge sort works as follows. It divides the unsorted list into n sublists, each containing one element. A list of one element is considered to be a sorted one. Repeatedly merge the sublists to produce new sublist until there is only one sublist remaining. That final sublist will be sorted list. The key operation of merge sort is merging of two sorted sublists. We merge the sorted sublist or subarrays by calling this auxiliary procedure merge. Here, this A is the entire array to be sorted. This merge procedure assumes that the subarray from index low to mid and from mid plus 1 to high are in sorted order. This merge procedure will merge the two sorted subarrays into single array. To understand this, let's take simple example. Suppose if we have two piles of cards. Let's call this pile as left and another pile, this one. Let's call this pile as right pile. Here, each of this pile is sorted with smallest card on top. Here, 2 is also on top. We wish to merge these two piles into single sorted output pile. What we have to do? Choose the smaller of these two cards and add it to the output pile. Repeat the same process again from this 5 and 3. 3 is the smallest. Add this to the output pile. Now compare this 5 with 7. 5 is the smallest, so add it here. Again compare 6 and 7. 6 is small, so add it here. Again compare this 8 and 7. Here 7 is smallest, so add it to the output pile. See here, this right pile is completed. Now we have only this left pile. The cards within this left pile are in sorted order, so all cards from this left pile will be removed and added to the output pile until this left pile completed. Suppose if left pile completed first, then all the cards from the right pile will be copied into output pile. Finally, output pile A will have cards like this. See here, in implementation, we use single array A. The elements from index low to mid will be copied into this left subarray L. Similarly, the elements from mid plus 1 to high will be copied into this right subarray. Suppose here low is 0, mid is 4, and high is 6. Then this left subarray will contain this low to mid, and this right subarray will contain from mid plus 1, 5 to 6. So they are stored in this right subarray. Let us see the summary now. This method will be called on entire array A from lower index to higher index. If lower index less than high means at least we have two elements, then mid will be calculated. Again, method will be recursively called on subarray from low to mid. Another method function will be called from mid plus 1 to high. This method recursive calls will continue until we have single element within the array. Low and high both are equal, then recursion will be terminated. When these two statements completed, this merge will be called with low, mid and high. This merge procedure will merge the two sorted subarrays. Here we need two auxiliary arrays. Let's call left subarray as L and right subarray as R. From this array A, copy the elements from low to mid into this left subarray L. From mid plus 1 to high, copy the elements into this right subarray. Now we have copied this lower part into L and higher part into this R. We need to combine these two subarrays into single sorted array. Here now we have three arrays. One is the original array A, and left subarray which is having the lower subpart of the array, and this right subarray which is having the elements from mid plus 1 to high. This L is sorted and this R is also sorted. Now we need to merge this L and R into single sorted array. So here we are taking three index variables. I will start from 0 and J is also starts from 0, and K which will be used as index for this original array A, and that will also be initially initialized with low value. If both of the arrays, this left subarray L and right subarray are having the elements, then we need to compare L of I with R of J, whichever is small, that will be copied into original array kth index. While doing so, one of the array might be completed, means all the elements from the either L or R will be copied into original array. Then we will be left with only one array, either L or R. Suppose if right part is completed, means array R elements completely copied into original array A. In that we will be having only left subarray. So anyway, elements from the left subarray are in sorted order. So we can simply copy all the elements within this left subarray into original array. Suppose if left part is completed, then we can copy all the elements within the right subarray into original array A. Here I am taking this array 6531872. Here n is the array size. This method function will be called with lower bound 0 and upper bound n minus 1. So this function will be called low will get 0 and high will get 6. Here low 0 less than 6. So this if condition satisfy. So mid will be calculated. Assume here this purple border as lower index, this blue border as high index, this thick red border as mid. 0 plus 6 by 2. Here mid is at index 3. Again method will be called on this left subarray from index 0 to 3. Means this method will be called with lower index 0 and higher index as 3. Here low 0 which is less than 3. This if condition satisfied here. Again mid will be calculated. Now mid is at index 1. Again, this method function will be called on lower subarray or left subarray. So method of 0, 1 will be called. Again, this method function will be called with low value 0 and high value 1. Low value 0 less than high value 1. Again, if condition satisfied, now mid will be calculated. Mid will be at index 0. Method of 0, 0 will be called, since here lower bound and upper bound both are 0. So this condition low less than high will be failed. So this function will be terminated. Again control will be returned to this method function. Within that recursive call, this first statement is completed. So now second statement, method of mid plus 1 to high will be called. Here low and upper bound both are 1. So this if condition will be failed. So this function will also be terminated. So control will be returned to its calling function method of 0, 1. Within this recursive call, we are done with first two statements. Now this third statement will execute. Merge will be called with lower index 0, mid index 0 and higher index 1. Now this function will execute. Low will get 0, mid will get 0 and high will get 1. We already seen method will use two auxiliary arrays. One to hold the elements within the left subpart and one to hold the elements within the right subpart. From low to mid, all the elements will be copied into this array L. From mid plus 1 to high, all elements from array A will be copied into array R. Here, left subarray has one element 6 and right subarray has only one element 5. Here we are taking three index variables I, J and K, while I less than n1 and J less than n2. Assume this red border as K and this green border as I and this blue border as J. Compare L of I with R of J, whichever is smaller, store that into original array kth index. Here L of I is 6, not smaller than R of J. So here R of J will be copied into array of K. Both J and K will be incremented. Now this condition will be checked. Now J is 1. Here n2 value will be 1. J less than 1. This condition will be failed. Here second array is completed. So we need to copy this first array, all elements into original array. So this while statement will execute. L of I will be copied into array of K. Merge of 0, 0, 1 is completed now. Within this merge set of 0, 1, these three statements are completed. So this merge set of 0, 1 is also completed now. So control will be returned to merge set of 0, 3 recursive call. Within that, we are done with this first statement. Again, second statement will be executed. Merge set of mid plus 1 to high. Here mid is at index 1. So from 2 to index 3 will be called. Merge set of 2, 3 is called now. Again, low less than high. So mid will be calculated. Now mid is at index 2. Again, mid set of low 2 and mid 2 will be called. Mid set with 2, 2 is called. So here it is single element. This if condition. Low less than high will be failed. So mid set of 2, 2 will be terminated. Again, next statement. Mid plus 1 to high will be called. Here mid is at index 2. So mid plus 1, 3 to high, 3 will be called. Here low is 3 and high is also 3. It is single element. So here low less than high will be failed. This function will also be terminated. Within this merge set of 2, 3, these two statements completed. Merge set on left sub array, merge set on right sub array is completed. Now this merge function will be called with lower index 2, mid index also 2 and higher index 3. So this merge function will be executed. Here low 2, mid 2 and high will be 3. So from original array, lower index 2 up to mid will be copied into left subarray, and mid plus 1 to up to high will be copied into this right subarray R. Here this L and R both having single element. Same previous process will be continued. Here K will be initialized with lower index and both I and J will be initialized with 0, I less than N1 and J less than N2. Here L of I compared with R of J. Here R of J is smaller. So this statement will execute. R of J will be copied to A of K. Both J and K will be incremented. Now K is at index 3. Here right subarray is completed. All the elements which are in left subarray L copied into original array A. So now this statement will execute. Within this merge set of 2, 3, all these three statements are completed. Now this right subarray is also in sorted order. Again control will be returned to this merge set of 0, 3. Within this merge set of 0, 3, these two statements are completed. Merge set 0, 1 and merge set and higher subarray 2, 3 both completed now. So merge will be called with lower index 0, mid index 1 and higher index 3. From original array, lower index to mid will be copied into L. From mid plus 1 to high will be copied into this temporary array R. Here these two elements copied into L and these two elements copied into R. Again I, J will be initialized with 0 and K will be initialized with low. This thick red one is K, this green is I and this J. L of I will be compared with R of J. Here R of J is smaller, so this statement will execute. One will be copied into array of K. Both K and J incremented. Again L of I compared with R of J. Again R of J is smaller. So this statement will execute. R of J will be copied into A of K. J and K will be incremented. Now J is 2 and N2 is also 2. This right subarray R is completed. All these elements from the L will be copied into original array A until this left subarray L completed. After copying all elements, this merge function will also be completed. After completion of these three statements, this merge set of 0, 1, merge set of 2, 3 and merge of 0, 1, 3, all the elements from index 0 to 3 will be in sorted order. Now control will be transferred to this merge set of 0, 6. Here only merge set of 0, 3 is completed. Merge set will be called on the right subarray from index 4 to 6. Merge set of 4, 6 will be called. See here this lower index 4 and higher index 6 since low less than high. This condition is satisfied. Mid will be calculated. Now mid will be at index 5. Merge set of 4, 5 will be called. Means merge set on this left subarray 8, 7 will be called. Here 4 less than 5 mid will be calculated. Here mid is at index 4. Mid set of 4, 4 will be called. Here low and high both are same. So this if condition will be failed since array having single element. So next function mid set of 5, 5 will be called. This is also single element, so it will also be terminated. Now these two statements completed. Merge of 4 comma 4 comma 5 will be called. Now this function will be called with low 4, mid 4 and high 5. Here merge of 4 comma 5 is called. From index low to mid will be copied into L. From index mid plus 1 to high will be copied into R. I initialized with 0, J initialized with 0, K initialized with low. L of I compared with R of J. Here R of J is smaller, so it will be copied into array of K. R is completed now, so all the elements from L will be copied into original array A. Now this merge of 4 comma 4 comma 5 is also completed. So these three statements within the merge set of 4 comma 5 is completed now. So merge set of 4 comma 5 is completed. So control will be transferred to merge set of 4 comma 6. Within that, this first statement is completed. Now this second statement mid plus 1 to high will be called. Here mid is 5, so mid plus 1 means 6 to 6 will be called. Mid set of 6 comma 6 will be called. Here array is having single element, so this function will be terminated. So within the mid set of 4 comma 6, first two statements 4 comma 5 and merge set of 6 comma 6 is completed. Merge of 4 comma 5 comma 6 will be called. From index low to mid will be copied into L. From mid plus 1 to high will be copied into R. I will be initialized with 0, J initialized with 0 and K will be initialized with low. Array of I will be compared with R of J. Here L of I greater than R of J, so R of J will be copied into original array. Both J and K will be incremented. This right subarray is completed, so all the elements from the left subarray L will be copied into original array A. Now this merge of 4 comma 5 comma 6 is also completed. So all the three statements within the merge set of 4 comma 6 completed now. So merge set of 4 comma 6 is completed. Control will be transferred to merge set of 0 comma 6. Here this first two statements merge set of 0 comma 3 and merge set of 4 comma 6 completed, means within the lower subarray all the elements are in sorted order. Within the right subarray all the elements are in sorted order. So we need to merge this lower subarray and higher subarray in sorted order. So this merge function will be called. Merge of 0 comma 3 comma 6 will be called. Here low is 0, mid is 3 and high is 6. Again same process will be repeated. Elements from lower index to mid will be copied into L. Mid plus 1 to high will be copied into R. From L and last three elements are from R. Again I, J and K will be initialized. K is initialized with low value. Here low is 0. I, J both are also 0. Both I less than N1 and J less than N2. L of I compared with R of J. So this one will be copied into original array into the index K. Both I and K will be incremented. Now I is at index 1 and K is also at index 1. Again L of I compared with R of J. Now R of J is smaller, so R of J will be copied into original array A into kth index. Both J and K will be incremented. Again L of I will be compared with R of J. L of I is smaller. L of I will be copied into original array. Both K and I will be incremented. Again L of I which is smaller than R of J. So L of I will be copied into original array into kth index. Again I and K will be incremented. Again L of I will be compared with R of J. Here L of I is smaller than R of J. So L of I will be copied into A of K. See here this left subarray is completed. Now I will be 4 which is not less than N1 value 4. So this while condition will fail. So remaining right subarray will be copied into original array until it completed. Within this merge set of 0 comma 6 all these three statements merge set of 0 comma 3 merge set of 4 comma 6 and this merge 0 3 6 is completed. All these three statements are completed, so all these array elements are in sorted order now. Now control will be returned to main function. If we print the contents of array, all the elements will be in sorted order.